So I changed it up a little bit on that subtitle. I was trying to be very clickbaity when I came up with the title for this. But augmented reality, I think when it first came out, I think we could all agree it was maybe a little gimmicky. But I want to convince you that it's maybe not so much a gimmick today, and that in the next few years it will be even less of a gimmick. So just a roadmap for today's talk, and there's the pizza guy. We'll talk a little bit about the market. I wanted to show some examples, but I didn't want to endanger our stream by showing any copyrighted material, so we'll just have to maybe just refer to it, and if you guys are interested, you can look at it later. And then we'll talk about ARKit and the big 3 takeaways of tracking, understanding, and rendering. Then we'll cover some kind of sundry topics from ARKit 2 that I just tacked on as an extras segment so as not to confuse things. And then we'll just recap what we talked about today. So in the market, a number of things I want to look at today, just a couple of example apps that are actually making use of ARKit in a way that is helping them monetize, not just as, say, like something for a startup where you're trying to get a lot of users. And then a little bit about current hardware, and we'll say current in air quotes because a lot of it some of it isn't out yet, or it's very expensive. Maybe a little bit about rumors, and then just some thoughts on privacy that's interesting to think about that I suspect will be a big topic coming up in the next few years. So here we have, this is an app I wasn't even familiar with, and I'll have to look a little bit because I can't actually see the video playing on this screen. It's called Magnolia. It's your typical kind of like homeware stuff, and it's a pretty basic setup, just a scene kit setup where you can browse, add that object. I've moved my table there in this area where there's really good light. I'm not crazy enough to put a table in the middle of the room like that. And you can see this example would require very little code. You don't even need a native app to do this functionality. You could do this from a website just as easily. So you're able to see your products in home. Target's doing this. You've all seen IKEA, I'm sure, and then a lot of other companies are doing it as well. This one, I think, is actually probably one of the coolest ones out there. It's the Warby Parker app. I'm sorry I don't have a better looking model for this section, but it's all I could come up with on short notice. So this is using the face tracking API in ARKit 2, which we'll talk about a little bit more in detail later on. There are some makeup apps. I didn't want to traumatize anyone, so I didn't do that. But you can imagine, like, what if Apple had where you could see what you look like with your Apple eyeglasses on, or if it could do tracking of the side of the head, which it can't, maybe your AirPods, something like that. And then I'll throw this idea out there for some of you trucker hats, right? So hardware that's out there now, these bottom 2, we've all seen the HoloLens stuff, and this is where I wanted to show some samples, but I didn't think it was a very good idea. And the Magic Leap as well, which I don't even think that's out yet, right? But those are ranging in thousands of dollars plus a hardware setup, like an external computer to do that. So those are not a consumer level product that we're talking about there. But when you look at, say, like this Garmin cycling glasses, there's also another company called Solos that had a Kickstarter, and they actually did ship the hardware, where it's cycling glasses that can show like your wattage, your miles per hour, that kind of info that people are going to be looking at a bike computer. So now they don't have to look down. So that's a big benefit, and those products are like the $500 or $600 range. If you looked at the Facebook announcement, they had the Oculus Quest, and that was like $400. It's a VR helmet, but it does have AR capabilities. And if you're comfortable with Facebook owning the entire hardware stack, then maybe look into getting one of those. And we'll talk about that, the privacy stuff, in a minute here. There are some Apple patents that are interesting. So maybe you could like edit a spreadsheet in 3D. So that'd be cool. And then we've all seen these things where you hold up a phone and see some augmented information of the scene you're seeing, but it's not hard to extrapolate to some kind of eyewear that could have that info for you. And then, like this one on the bottom left was interesting to me because it almost looks like he's got an Apple Watch up to his eye. And to my mind, that could be like your MVP product for something like Apple, which is like just a basic information display where a developer can pass like an array of data that populates a table view. Nothing too complex. And then you might keep in mind that the Apple Watch supports SceneKit and SpriteKit. They're 3D and 2D libraries, and it's actually surprisingly fast if you've played around with it at all. I was actually surprised. And then this third panel, this looks more like VR to me. If you want to look like one of the blue guys from the Alien series, that's a good look. One thing that all this AR stuff is making me think about, seeing some announcements for like Alexa glasses and the idea of Google Glass. We had a few years back where everybody freaked out about the privacy implications. And I think it means, especially for people who have bought into the Apple ecosystem and their privacy model, it breaks that model. Because if somebody like comes into your house or is talking to you and they're wearing those Alexa glasses, then your premium amount you paid for that Apple product doesn't necessarily buy you any privacy there. Particularly if we're talking about having like cavity well lasers on the back of the device that are scanning the depth of the room the entire time that it's operating. And we're already kind of seeing this with AR apps, because a lot of them, you download it, and I was looking at some of them, and I was like, I really don't want to grant this access to my camera system, because it just looked really shady, even though some of the demo videos and screenshots looked interesting. So enough of that stuff. Let's talk about ARKit and those three main things that ARKit provides for you. It's a very high-level API and very easy to get started with. And it provides three different things. It provides tracking, scene understanding, and rendering. I got to remember not to turn this way if I need to look at the screen. So your application sits, so to speak, on the shoulders of giants here. ARKit will handle all of your processing, and it's backed by AV Foundation and Core Motion. And then your rendering is going to be handled by one of three libraries. And we'll talk about those in more detail again: SceneKit, SpriteKit, and Metal. It's a session-based API, so you will need a session, and then you'll want to make a configuration right here, and then whenever you run that session, you'll pass it whatever configuration you want. And once you've made yourself the delegate for that AR session, your controller, wherever you want to handle these things, you'll receive notifications that AR frames are coming in. Whenever it has a new frame, it'll update you. And you can get additional information on those frames if you pass in the right configuration. So here we are with an example configuration. This is a pretty basic setup, just a world tracking configuration. This would be the one to default to if you just wanted to set up, say, like a SceneKit view where you're just dropping an object on the first plane you can see. And they're using some pretty good practice here, where they have a fallback in case the device does not support ARKit 2. So always check for that. Not a bad idea, right? A little defensive programming. And we can see a couple of different states that we have available to us on the session. We can run it, we can pause it. If you rerun that session and pass it back in with a new configuration, it will just resume with that new configuration. So if you want to add some capability, or if you feel you need to fall back from that capability and just go back to your base configuration, you can do that pretty easily. And like I was saying before, you'll want to set yourself up as the delegate, so you get these did update frames or your errors so you can surface those. If you look at Apple's example apps, they have some pretty good, some good examples of how to surface those errors in a way that means something to users so they can take action to fix whatever problem they're having, usually with lighting situations is my experience. One other term I just want to touch on is AR anchors. We're talking about that a lot. You can add or remove these to the session, and your delegate will let you know if they're being added or removed. So once again, ARKit does tracking, scene understanding, and rendering. We'll drill into these topics a little bit further, not in big detail. Like I say, they have great example code out there on their website. So it can track the position and orientation of the scene in your phone, things like physical scale. We've all probably played around with the measuring tape app, which is sometimes very accurate and sometimes wildly inaccurate based on lighting conditions. 3D feature points, and we'll see those in some of these examples, but if you use an app for AR and you see a bunch of yellow dots, that's the 3D feature point debugging has been turned on for that app. And that's what you're seeing. It's usually just like, sometimes it's a shiny spot or like a darker spot, just some contrast in the texture of the object or scene that you're looking at. And then relocalization, so it can, with ARKit 2, can hopefully pick that scene back up. Scene understanding. This one's interesting to me because when people talk about not just AR, without scene understanding, it's not even AR without that. You could have the rendering, you could have the tracking, but you would just be placing an object in some scene and nothing would happen and it would have no value. It's similar to me when people talk about, say, like voice interface being the next big frontier. And I think back to the 90s where like my Mac I could talk to it and it could read things to me, but it didn't understand any of those things. So we've had those things for a very long time, but they had no value without any machine learning or understanding on the other side. So the most useful thing that you're going to be using is plane detection. Usually you're going to be finding like a horizontal plane, but they now added vertical plane detection. I don't think it works very well. I kind of wonder if they should have kicked it to ARKit 3. I don't know if anybody's worked with that at all, but it's very touch and go, but the horizontal plane detection works very well. Hit testing, that's those yellow dots, again, that you'll see across the scene. Light estimation, that comes in handy particularly for SceneKit, where you want to have those objects look like they exist in the lighting conditions that you are in. And you can actually build like a cube map that goes around your object. It can build that out automatically for you so that the lighting is correct. 3 new ones that got added, and we'll cover these, and I have some video demos of them, but object detection, which is very touch and go, image detection, which works pretty well and is extremely easy to get started with, and then a little bit about the front-facing sensors on the phone. So if we want to do object detection, we just need an AR world tracking configuration, and then we want to pass in an array of our objects. These objects could exist in our asset catalog. They could also exist in the file system. And then we want to run our session and pass that configuration. And you can see here, same thing, except for in the sample I'm going to show you, we'll actually be scanning in our object first live on the phone, and then saving it to file, and then recognizing or attempting to recognize the object from the file system. Since you've set yourself as the delegate, whenever it detects something, you will get an AR object anchor. It will add a node to that, so you can inspect that and see that you have objects detected and take action accordingly. This is a very long example. It's one of the longer ones, so I'll try to not ramble too much while it goes along. But here I am trying to scan this hat in. You can see it has good contrast. So it's a very good object, very 3D. And you can see all the yellow dots there are feature points, and then that bounding box. I'm going to resize it a little bit just to demonstrate it. It probably messes the model up a little bit, frankly. But once we've scanned it in, we can actually share this out, even add it to an asset library. And then once we have it scanned in, we'll go to the next slide. And it's recording all that information. You might even see like the world origin for that object, like the 3 axes indicator. It should pop up when I'm done scanning the object. Okay, I think it looped. So now we're on to the detection phase. I'm going to move it just to see. So I detected it, like big whoop, right? It was in the exact same position as before. I move it, I rotate it 90 degrees here, and it's having trouble. It's struggling. So I'll turn it back to the original orientation, and we'll see what happens. So there we go. So not super reliable right now. If you have absolute control over lighting conditions, then this might be something that you could use like in an installation, but it's not going to work reliably for you out in the wild. Just notes on that hat, you notice it's very well textured. It is a somewhat rigid object, so it's not moving around and it's not reflective. Anything shiny at all, like this cup, you're not going to be able to scan it, and you're not going to be able to detect it reliably. And it's very easy to add these in, and we'll cover that a little bit. Since we're talking about scanning objects, I thought I would just show you this. This is from the front-facing camera. I tried to scan something other than my face, but it was extremely difficult because you can't see what you're doing. But you can see the density of this scan is so much higher than the other one. There's like 150,000 points there. So very high detail map. Definitely food for thought when you're giving access to apps to those front-facing sensors, and then looking maybe even the next generation of phones or two. I would be very surprised if we don't see some kind of room scanning, say like a cavity well laser. The limit on this one is about 2 feet approximately, so if you move it away from your face, you'll see it can't actually detect you anymore with that infrared sensor. But if you're talking about lasers, that could be, could be 10, 20 feet of scanning capability where it could scan out the 3D space that you're in. We'll cover image tracking. This one, I think, I could see a lot of people getting like an easy win with this one if they were building an app. It's extremely easy to use. I just took a photo of 2 books that I have and then added them to the asset manager and then ran the demo. And you'll see how it works in a second here. So we set a configuration for image tracking instead of world tracking. We're actually going to pass in a world tracking configuration too, since we want to show the camera image while we're doing this. And here's a theoretical list of things. We're not actually looking at cat and dog photos. And we can set a maximum number of images that we detect at one time. On this sample, you'll see that it's going to only detect 1. Much like the AR image or object anchor, we will get AR image anchors added in whenever it detects an image, and we can act accordingly. That book on the right cracks me up. It says it's worth $600,000 on the cover, so I'll see what I can get for it on eBay. But you notice it recognized it pretty well. The first one, it was able to get it at even a 90-degree angle. The other one, not so much, just because the cover is kind of high gloss. It made it a little harder to do. So this one, very, very easy to use. I highly recommend looking at this sample if you're interested in this technology at all. Let's talk about rendering for just a little bit. We have 3 different options. It's very, very easy to integrate. It's really, if you just start with the templates, you can choose one of 3 templates for SceneKit, SpriteKit, or Metal, and it will set up everything you need. And it may not be exactly how you want it set up, but it's a very good starting point. So SceneKit, if you're doing 3D, I recommend starting with this, particularly if you're doing object placement in a scene. If you're trying to make like a simpler game, maybe SpriteKit's the way to go. And then I can't imagine, it's hard to imagine who needs Metal other than companies like Unity or Unreal. I'm sure there are people out there that need it. I don't know. If I'm wrong, let me know. But I think this would be last resort if you've already proved you cannot achieve what you're trying to do through other means. So SceneKit, this is just one of their built-in samples where you can see these somewhat realistic-looking objects on this table. The lighting doesn't look great here. It's much more convincing in person than it is on video, as I'm sure you all anyone who's played with the sample knows. So we're getting that captured image from the camera, we're displaying it, and then it's updating. We have a SceneKit camera that is aimed in the same direction as us all the time so that we're seeing it from the perspective that we need to see it for AR, and it's automatically taking care of the lighting. And then whenever we add these objects, it's just appending those nodes to the node tree at those anchor points. So if you're familiar with SceneKit, it's very quick to get up and running with that. SpriteKit, very similar. You need another AR session as well. It's going to draw that captured image in this default mode, and we're just setting sprites to anchor points. And this isn't the best video. I should have shot another video of it because I should rotate the phone because they're always billboarded. So if I moved around the scene, you would see those Space Invaders are always facing us. Then Metal. I don't have a good example of this other than the built-in one. This is very basic. This is an advanced library. You don't want to use this unless you absolutely need something like this. So, but you have override points for all these things that you can handle on your own. And you see it looks pretty basic right now without us doing anything to make it look more realistic. If you're wanting to make a game, probably, unless you're just really wanting to do it in Swift or Objective-C, probably look at Unity 3D or Unreal Engine. And they have plugins for this. So extras. These are the things I couldn't fit into that structure of the talk. Some new things that came in, like world maps, I'll talk about briefly. These are extremely cool. It was just me, so I wasn't able to film part of it, but where you can actually save that world map that you've scanned, so your scan of the room where you know where everything is, you can serialize that to disk. And in this demo that Apple has, they're serializing that and then sharing it out to the other phone, so you can have a shared gameplay experience, allowing for multiple users. And then even if you're not wanting to support like multiplayer experiences, it's also persistent. So in ARKit 1, you leave the room, that's it. That little AR world is gone forever. If you serialize this to disk, you can load it back up on that room and persist whatever was going on. So that should give you, hopefully, some food for thought if you wanted to make anything that would take advantage of that. Face tracking, I personally think this is one of the cooler things that's come out in a long time. So you can almost imagine a mouse stick interface with these lines, particularly if there were goggles. This is actually a texture map, but it maps very closely to the debugging AR face mesh that you get provided. So it doesn't give the exact data of your face, but these 50 facial feature points. This was very easy. It actually just said AR, and I just dropped in some sunglasses from TurboSquid, so they were royalty free. And then textures, so you could have any video on there that you want. And then, of course, rigged 3D objects like Animoji. I never get that name right. I think it's Animoji, right? That's not the best example on that cube face, but if you have access to an artist who can make that kind of stuff, you have up to 50 different facial features that you could rig that model up to. Here's the audio. It works. Great. Okay. So this one, it just places this fireball at the first plane it sees. You see, as I step away, slowly walking away from the fire, we hear it gets quieter. This is pretty easy to set up. If you're using SceneKit, you just need an SEN audio source, add it onto that node structure that you're placing at that anchor point, and then tell it to run. If you had a lot of stuff, you would probably not want them all running all the time for performance reasons, but a small example like this, not a big deal. This is another $1 million app idea, it's Fart Apps, where you maybe have a little noxious looking cloud you could leave, like at persistent locations, right? And it could play like sounds when people come up there. If anybody remembers the original Gold Rush on the App Store. Debugging options, there's a lot of them, particularly for SceneKit. I've just turned on a ton of debugging options here just to give you an idea. So we pop a lamp up here and we see the bounding boxes for the object. We see a dog running around the scene, that's weird. And then we can see things like the origins. We can't see any cameras because there's only one camera in the scene and it's lined up with my physical camera of my phone for the illusion. But you have lots of options available to you. And then of course in Xcode you have some pretty good debugging options as well. That said, hopefully you're not dealing with issues with your specific models in your program. Like you would definitely want to try to isolate those things and fix them separately if you're having an issue with that. So in summary, SceneKit, it's an amazing API. It's very easy to access. There are companies out there helping themselves monetize by using it today. So it's very easy to write it off and say our company can't do that. But maybe it can. Maybe there is some way that you can add value with this API. It does tracking. It does scene understanding. It does rendering via the other provided libraries given to you by Apple. It is a session-based API, so recall when you get started, you will need a session, you'll need a configuration, and then when you run that session, pass it your configuration, and then set your controller, as the delegate for that, and you will receive these AR frames here. I just have a quick reference slide, and then I'll open it up for questions. Apple has a very good landing page for ARKit. I think the better page is the second slide, or the second link. And it actually has all of the AR videos from WWDC, and then a couple of like VR and SceneKit videos, which it wouldn't hurt to look at those if you're actually very interested in this topic. I think I wanted to show this as like a 2-minute clip, but I seem better not to. Just Google Magic Leap example. It's about 2 minutes of actual recording of the actual Magic Leap interface. And I think it's not hard to extrapolate with, say, like an Apple or even an Android UI, if that's your thing, being projected in front of your face in an intelligent way that adds context to what you're looking at. And then a book recommendation. I must be listening to too many podcasts. Snow Crash, it's a very old book. It's got a lot of VR and some AR stuff in there that I think is a fun read. So. And that's it. I'm open for questions now if anybody has any. I didn't have a 10, so I can't answer that personally, but I think, Oh, yeah, yeah. Is there a big difference on hardware? I'll learn to do this one of these days automatically. So is there a big difference between the hardware generations on this? And I would say the 10 is the big demarcation point. So you get those front sensor arrays, and then I'm trying to remember maybe about the 7 or so, because when ARKit 2 was in, like, before it was completely public, I had like an iPhone 6 Plus, works great. But when it came out, it was no longer supported, probably for performance reasons, just because if you had a lot of triangles in your scene, then it was going to slow down. Anybody else? I promise to repeat it this time. I want to remember. Oh. And I'll be around here a little bit too. Yes, Billy. Oh yeah, he's asking about the format for storing AR objects. Apple had they co-developed this format with Pixar. It's called USDZ. It's actually pretty cool. When you, that scan of my face, that was actually a USDZ object. Adding those directly to a scene, I tried that, you can't do it, and Xcode freaked out. That took like several minutes to like resolve that. You would want to convert it to like an OBJ file, ideally, and then or DAE, and then like import it into your scene at that point, and it would be part of your node structure at that point. I guess conversely, you could just not have a scene and then load that USDZ in there. And I haven't looked into the format enough to know if it's really just SceneKit. You know, if it's the same thing, it may be. Okay. Oh, yes.
So, say you're doing this on something of considerable scale, where you have team resources dedicated to this.
Right.
Are there standard programs other than what Apple provides to generate these objects? Like if there's a designer or artist that's creating them, like, you know, is there graphics like rendering that they would generate them and then send them to you as a developer?
Right. I think so. The question, if I can recap it, is it how do you get these assets generated if you're working on a large team? Short answer, I don't know as a programmer, but longer answer, it just depends on what your team, what they decide, whether they want to purchase assets or build their assets out in their 3D editor of choice. I know enough to be dangerous, like in Blender at this point, just to get stuff done. So that's, if you're looking for a tool for a side project, that's a good one. It's free, but you're going to be watching a lot of YouTube videos in order just to do the most basic stuff. Yes?
Can you persist the scanned objects that you scanned with the ARKit?
Yes.
Bring them up later at a time?
Can you persist scanned objects? Yes, you can. And you could save those to the file system. You can serialize them and then do whatever you want with them at that point. So ideally, maybe if you, let's say you had a museum exhibit, you would scan those objects, save them, then add them to your asset library probably, and then have those just deployed with the app, and then it would be able to recognize those objects. And I never stopped for pizza. Everybody's starving. Sorry.
Does the kit differentiate between the front-facing camera or rear-facing camera?
Does it?
Like that hat example on there, if you were to go ahead and scan that object, have it recognize that object, could you then, like, for instance, put on that hat and then have that object turn into other stuff? Like, does it actually keep the information accurate enough between the two?
So can you ask it again? I'm sorry, I don't understand. Yeah.
Does anyone know I'm better?
So you're saying could it recognize two objects that you had put together, or?
So that example you gave with it recognizing that hat on the table, if you got to scan in the hat and be able to recognize the hat, then put it on other objects or on yourself, and then
Yes, you should be able to.
front-facing camera, would it be able to recognize that?
Okay, the question is, if you scanned it with the front-facing or back-facing camera, could you observe it and detect it with the other camera, right? Is that close enough? Okay, so the hat I scanned with the back-facing camera and then detected it with the back-facing camera. I don't see any reason why you couldn't detect it with the front-facing camera. the kind of bust image of my face, I think it would be able to detect it as well. But you would probably need to simplify the object because it had so many points on it that I don't know if it could handle it, that many points. You would need to reduce the complexity of the object probably, but I didn't try, so it may be able to do it. And I'll go ahead and stop now, I guess, because the pizza's here, and then if anybody wants to talk about ARKit, I'll be here. So thank you.